single node or single chip result. For instance, some of the Intel results and AMD and so on. So this isn't all full system information, but you can see where a number of the big players are in the space. Certainly IBM, Cray, Convey, etc. And now a view of the top 10 Graph500 entries. So what I have in the first column is the rank in Graph500. And we've tried to break out the machine name, the vendor that has integrated it, the model of the machine, the installation site, the country, and then some features about the machine, the number of nodes in it, the number of cores, the main memory size, and this is the problem scale that was run. So again, this is log base 2 of the number of vertices in the graph. So scale 38 means 64 billion vertices. And then the normalized gigateps, or billions of edges traversed per second. So on the sheet we see a number of architectures, and we just went through the top 3, but we also see some HP's cluster platform from Japan. We see SGI, the ice system at NASA Ames, Cray XC6, another Blue Gene, and so on. On these rankings, though, there's been a lot of questions about, does this ranking Graph500 correlate with top 500? In fact, that was asked as a question here a year ago. And I think we finally have enough data where we can take the machines on this list and find their corresponding entries in the top 500 list. And this week, the 39th top 500 list was released, and that last column has the approximate system and where it's ranked on top 500 when that machine is in both lists. So I say approximate because if I look at Sequoia, for instance, that is a full machine for top 500 versus a subset of the machine for Graph500. The architectures are both the same Blue Gene machine. And what I notice here is that, yes, the top 10 machines here are in, say, the top 100 of top 500, but there's no direct correlation per se. So if I look at the top 500 rank, they're not monotonically increasing in rank. I go from 1, 3, 23, but look at what happens down here, 99, 11, 6. So I think that we can start to conclude that top 500 and Graph500 are really measuring different aspects of a machine. There's some loose correlation, but there's no strong correlation between these rankings once I start going down the list. And again, this is just for the top 10. We haven't yet done a full analysis to try to match up to the full Graph500 list. I should also mention that there are Graph500 machines that will never appear in top 500 because they're not able to do the floating point capability. So we do have cases where there are unique architectures in Graph500 that will not be ranked in the top 500. Any discussion or questions about this slide? Okay. The other just-in-time slide that you see.
You had a
question. Yes.
You don't have the Islamic Q name on the machine list. Yeah. Minor correction. Thanks.
See, we run into problems, we fix them.
Thank you very much.
So on the minor changes for the 10th ranking, so then we just submit the score for the CPU-based version of the Tsunami. So that number is over 200, around 200 something. So that should be the 10th rank.
Okay.
We'll update it.
Yeah, so we'll update it. Again, we're learning as we go, and so if you have concerns, get them to Rich and I,
Okay.
and we'll try to address those. So the other just-in-time slide that we have here is, again, this was literally done a minute before I started talking here, but we're looking at this plot which is, has the axis switch from the charts that Peter shows. On the x-axis, I have performance in taps, gigataps, so to the right is higher performance. And on the y-axis is the problem size solved, so higher is a larger problem. So this little bullet all the way on the right-hand side is the furthest to the right by almost an order of magnitude, that factor of 7, and that's the #1 run on Sequoia and Mira with over 3,500 gigataps. And then the blue gene systems are in these red squares. x86 machines are those little diamonds, blue diamonds. Cray XMTs are the green triangles. Convey has 9 systems, which are X's. Ultraviolet is on here. And then other are machines where, from the list, I couldn't figure out what they were 10 minutes ago. So I put them under other. So it doesn't mean that they're not an x86 or other platform. I just wasn't sure how to categorize them yet. So one thing I should note is you see performance, there's a rough correlation with problem size in some sense that we're starting to see. But we're still not sure, and I think Torsten and others will talk more about that. The other thing that I should mention is that if I look at problem size and take a horizontal cut, there are problems below a cut, a small problem, where they're fitting within a single node or chip, and above that line they're going out to remote memory. So you have to keep that in mind, that you'll see this cut somewhere in the middle of this chart, where we go from a problem that fits on chip to a problem that requires a full system. And again, we start to see some clustering happening in here among the x86 platforms, the Blue Gene platforms, and so on. So just to highlight the fourth list to conclude here, the #1 platform that we have on the list, that's the Sequoia and Mira platform. The Blue Gene Q have increased their performance by over an order of magnitude, actually a factor of 15, from the 3rd Graph500 list back in November at Supercomputing 11 to the 4th list here at ISC. So that indicates some very strong work in custom algorithms, some very good job of tuning these for the architectures. Also, many of the more the novel single node results have significantly improved their performance and efficiency as well. For instance, take a close look at Convey, which has done a very good job with their graph personality, as one example of a novel implementation of this, among others. And also, as I mentioned before, I think we can start to conclude that Graph500 and Top 500 are not strongly correlated. This will be something that we'll further look at with the full list and as we go out in the upcoming years. And this last bullet I think I meant to edit, and I must have lost my changes, but larger graphs, there's some relationship to performance. We're not sure whether or not they truly give higher performance, but we're still trying to figure this out.
Can I add something?
Sure.
Even if we have time. So one of the things that we were worried about in the original list was that somebody would create a cached, some sort of a very small cached graph and get very, very high performance. And I think what we've noticed is that by now people have to have a large enough graph thrown at the problem to get enough memory controllers on a supercomputer to actually solve it, but that's not at all a problem. And so you may not see people running the largest possible graphs on their platform to get the highest test rating, but it's close. It's reasonably close.
Right. For the largest runs, we often see the graph running as maybe half the graph size of what could fit in memory. So they may be able to go out one more scale, but then the performance may drop. So we do see people running almost the largest problem they can solve on their system to get the highest score, which I think is reasonable.
I just want to note that, in our runs, we've seen that fairly consistently, that you go out and you see slowly growing performance, and then you get to that last one, and the performance drops by like 10 or 20%.
So let me finish up here, and I mentioned single source Shor's Cat. A full spec will be out at November 2012 at SC 12. And also the 5th release of the list will be there. Any quick questions before I switch speakers?
So, WinPack is pretty clearly something that the HPC community cares about and no one else really does. But the graph algorithms are of great interest outside of high performance computing. So, in
So
Yes.
Google actually joined the steering committee last year, as did Bank of America and a few other people I can't remember off the top of my head. And what they essentially said is they're not going to submit to the list, but that it was one of the few benchmarks that they found truly relevant to their data set. And so hopefully we can make it more relevant to that community in general. I don't know that you'll actually see a Google entry because it would, I don't know, could potentially be highly disruptive, I suppose. But we would
But
definitely
I
take
think, I mean, the short answer though is that we would welcome it from any industry that would like to submit. And the other thing that we don't have are cloud computing results or say Hadoop MapReduce results. We'd look for other architectures that I think will be interesting in the big data space. We would encourage those as well. But we haven't seen those entries yet.
I have gotten some informal cloud results from a number of places, and the fear is that they, on their behalf anyways, that they don't place as well because they typically start out poor.
A quick question, when the reference implementation of the SS6P is going to be available?
When is the reference implementation?
I can make
We have one, don't we?
I think we do. So get in touch with the organizers. We have a spec, and I think we have a reasonable reference implementation.
We should probably post those for comment for the next
Correct.
one.
So after this meeting, we'll try to broadcast to the steering committee and also update the graph500.org website. So check there.
So we're gonna continue ranking on the first kernel while we collect data on the second kernel to calibrate,
Are
essentially.
you collecting data on the second kernel for SC12, or are you?
We will collect data on the second kernel for SC12, but we won't rank on the second kernel.
Okay.
Okay.
Because
So let's,
I saw that you said you were going to give the spec on at SC12.
for the sake of time, I think we
Yeah, we
should
should move
switch
to
to Torsten.